Devin Barrera.
Thank you so much, Nikki. Good afternoon, everyone, and thank you for taking the time to join us today as we take a little bit of a deeper dive into Astava and the solutions in which we've been able to partner. I'm Devin Barrera, Business Development Manager, specializing in pressure applications and all the accessories that come along with those applications. And today we have the pleasure of Caleb Liao, Global Manager for Astava, joining us as we will be presenting some problems and solutions that we've been able to provide in the industry. We'll move forward.
Yeah, so thanks, Devin, for the introduction, and it's a pleasure to be with everybody on the webinar today. The agenda really is to go over a couple of the areas in Astava's portfolio in which we've been able to solve challenges for the customers. And so we've broken it into a section talking about how instrumentation manifolds have been able to solve challenges, but also turnkey solutions with flushing ring assemblies and instrumentation hookups. And then finally, showing the interlocking manifold, something that we developed 40 years ago that has really been able to solve a challenge, particularly related to sill-rated systems or high integrity pressure protection systems. So with that, let's get into it. Astava, really quickly, is a company that was founded in 1956, and we're based in Meppel, Holland, which is about an hour and a half east of Amsterdam. The company really started with the instrumentation needle valves, and out of customer demand grew into manifolds and instrumentation hookups. Today, we really focus on solutions, and we're really focused on solving challenges for the customer. So there is a component of our business that produces standard products, but we also have an affinity for, a bent for providing customized solutions as well. And hopefully we can show you some of the creative things we've done for our customers today. Really, our service and product range is broken into 3 sections. You've got your traditional business of instrumentation valves and manifolds, package solutions, and safety related. And so the first we'll talk about is instrumentation manifolds. Really lead this off with 2 images because these are the 2 main portions of solving a challenge. 40 years ago in the North Sea, Shell asked us to develop a solution for them. The first problem that they were having was they were experiencing failure or a lack of reliability in their instrumentation needle valves. Basically, there was a gas application, and so they were choosing soft-seated needle valves to provide a reliable bubble-tight seal. Challenges when you are looking at instrumentation manifolds or needle valves is that when you choose a hard seat, you get greater durability and reliability of that valve, but traditionally have always selected a soft seat to make sure that there's a bubble tight seal. And so when they asked us to find a solution for them, we started playing around with different materials, and we came to the market and we came to the customer with a solution of using ceramic tips in our manifolds. What we found was that there are an array of benefits of using ceramic, none less than the fact that it both provides a bubble tight seal and the durability of a hard seat valve. The second part of it really had to do with providing instrument reliability, and the key word here is availability when it comes to the interlocking manifold. We'll talk about that specifically towards the end, but they needed a way to mechanically ensure that their instruments would be available. And so we made these 2 innovations and provided that solution. I think what I want to stress in this first part here is that when we introduced ceramics into our valves, we found it was such a good solution, we decided to standardize on it. And so we use an AL203 ceramic needle tip, which it has excellent chemical compatibility. It's more than 10 times harder than stainless steel, which allows the ceramic to make sure there's a snug and customized fit against the ball every single time you close it without using excessive force. One question that we got when we were developing this was, ceramics may be good in terms of hardness And in terms of chemical compatibility, it tends to be a hard and brittle substance. What we found is that when you make ceramic into a ball, it is incredibly resilient. And if you're familiar with any of the videos that we've put on YouTube, you'll notice one thing that we do where, it doesn't matter what the alloy is. Mainly we test it against 316 stainless because that's the harder alloy that we have. But using the stem tip, we'll make indents and find those marks. So if you're interested in seeing that, please look us up on our YouTube channel, or maybe the next time we get to visit, we'll be able to talk about that in detail. But I think the main things to take away here is that Astava's core differentiation is our standardization on ceramics, and that came out of a customer's need to solve a problem, to develop a hard seat durability valve, but with gas tight sealing performance. And we've been able to prove this in the oil and gas and petrochemical and chemical industries for over 40 years now. And so we've taken that and we've applied it to our entire product range. Sorry, went a little too far there. So you'll find it on monoflanges, 3-valve manifolds, 5-valve manifolds, air distribution manifolds, all kinds. We've really found, great use out of the use of ceramics. And hope to talk to you guys more about that, and especially if you have any questions about using ceramics in manifolds. Okay, that takes us to the next section, talking about turnkey solutions, particularly with flushing ring assemblies and instrumentation hookups. But because Devin has been intimately involved in actually developing these solutions with the customer, I've asked him if he would be able to share the story behind some of the solutions we've developed. So Devin, would you take it from here?
Absolutely. Thank you, Caleb. This kind of gets me pumped up to talk about, guys, but something as simple as a flushing ring, as you can see here on your screen, we have 3 different components to it. We have our flushing ring, we have nipples, and we have an accessory on the end of it. This one just so happens to be a valve. So we had a customer that came to us and said that his plant was moving away from threaded connections and in anywhere possible. So first and foremost, he needed a solution in which we could provide him a flushing ring that had no threads and all welded connections. Second, he was telling us that it was a bit more difficult and time consuming to find this kind of solution because he had to reach out to different manufacturers or distributors to piece all of this together and then do all of the welding in-house. So we came to Vector and we partnered with Astava and were able to provide a full turnkey solution in which we welded the flushing ring, the nipples, and the valves to the end of it. This specifically looked like the picture you're seeing now, in which he needed flanges on the end of it and not valves. I got ahead of myself there for a second. But this is a rendition of something similar. As you can see, we're able to do all socket welds all along this flushing ring for him. We were able to do all kinds of PMI testing, dye penetrant testing, X-ray testing, and we were able to provide a solution. So Caleb, if you move forward, we actually got lucky in which the customer was so satisfied with this. He sent us pictures and was very, very pleased with the way it worked, in which it allowed him to standardize on all of his packages moving forward. So this was actually in an HF application. So we had to do it. We had to make it out of Hastelloy C, in which very difficult to weld, but nonetheless, we were able to provide him something, and it's still in service to this date. And he's continuing to move forward and thanking us for all of the problems that we've relieved him of.
Yeah, cool. Yeah, it was a fun one for us to be able to find a sweet spot in our skill set and what he needed.
Absolutely, and we'll move on to this. Caleb, do you want to share the story about what happened here?
Yeah, absolutely. So after we had that opportunity, a different part of the plant heard about what we had been able to achieve for this HF acid application, and so they asked us for a flushing ring, but in a kind of different way of using it. Basically, it was running off of a coker unit. They had 2 piping spec valves, the primary isolation valve and the secondary isolation valve. The challenge here was that when they blocked in the primary isolation and the secondary, they needed to be able to release pressure that was trapped between the primary and secondary isolation valve. And the practice that they had been employing was calling out a team, a crew of 4 men, and also the fire department, in this case, to be able to unbolt a blind flange. But after we got talking about it and he had seen what we did with the flushing ring, we were wondering whether or not we could sandwich a flushing ring between the primary and secondary isolation valves and then bleed off pressure to atmosphere using instrumentation spec valves. That way the instrumentation group could basically take care of everything on its own. And so we started sketching on the back of the piece of paper on the back of the truck and just started looking at what we could offer here. So what you see from the drawing or from the picture is that the primary isolation valve that's coming off the flushing ring, that is a outside screw and yoke bonnet piping spec valve. It's a fire safe valve. So it maintained that integrity that they needed as a secondary block coming off that primary block. And then we welded on a bleed valve, which you can see coming perpendicular off of the valve. And then also the customer wanted to have access to the valve in the future, just want to have that option, right? Because on one end, you can, when you open up the bleed valve, not only does it release out of the bleed hole, but there's an 1/8 inch MPT connection there. So you can tap in back in there if you needed to. But the other option that he wanted was to have a way to go in there by double ferrule compression fitting. So we machined a double ferrule compression fitting end connection to this valve, and then we put on a plug, which really increases the ability to reuse that connection over and over and over again. And then we duplicated that solution on both sides of the ring so that there's redundancy there for the customer.
It's kind of funny, we kind of chuckled here when Caleb said, hey, we started drawing this on the back of a truck, but really guys, this is what it was. We knew, give or take, what the customer needed, and as we started to give more ideas, he kept asking, saying, hey, can you do this now, because I see this to be an issue. There were multiple renditions of this, and it was honestly really fun. We were able to provide him a solution, and at the end of the day, he standardized on this for all of his cooker units now. So we've been able to provide him a big help in providing a solution.
Absolutely. And shout out to Max Schiff, really for tying all this together. It has been really fun to work as a team together on this. And then here's just other pictures of flushing ring assemblies, but wanted to show you one in a ball valve coming off of the flushing ring. And then finally here, it's not welded, the valves aren't welded on here, but you see that a monoflange, which is like a block, in this case, it's block bleed monoflange, is integrated together with the flushing ring. And it gives more, there's more options there, less connection points, something that this particular customer in Europe for this configuration was looking for. But it's something that we're highly accustomed to doing, and we love finding solutions. Okay, so this next one, Devin also was very close in on, and the solution is in that picture right there. But let me just run through it. When we talk about instrumentation package solutions, especially in a remote mounted, this is a MESC ordering process from Shell. It's a 6-step process to selecting all the components you need in a remote mounted system. And we really followed this template to be able to find a solution for the customer. So would you talk a little bit more about this one in particular?
Yeah, absolutely. So there's some pictures that the customer actually gave us from the application itself. And this one was actually very interesting because the customer had asked us to come walk this down. We walked it down, and overnight he ran into the same issue in which he was trying to avoid. The person on call had to come in and fix it. So here you'll see wrapped, it's actually a steam trace line. So he has a DP transmitter and a manifold, which the handles are the only thing exposed. The reason he was using this DP transmitter was because of the heat coming off of this line. Well, if you're having to replace this, in his words, he was having to replace it every 2 to 3 months. You have to unwrap all of your steam tracing, manipulate everything, replace it, take everything down. So his issue was time, downtime, and money. He was losing so much time in his process, which was costing him money in the downfall. And so he was asking us, is there anything that you can do to help us solidify this process, make it easier for us to manipulate? So we went to the drawing board, and the next day he called me and said, hey, the guy had to come in, we had to shut it down, and he had to unwrap everything because the transmitter had failed and we didn't have our primary measuring device here. So our solution is, as Caleb pointed out, is on the right, in which we were able to provide him a plug-and-play solution in which he can still have all of his steam trace wrapped, but there are two compression fittings in the back of the mounting plate in which he can run his process and the steam tracing through. So going from the bottom up, you see we have a junction box which is led through a red wire, and that red wire is actually heating that block there. So that block will keep the process at the same temperature. Above that, we have an H profile manifold, which allows a little bit of dissipating heat to come off and not affect our transmitter electronics as much. All of this is enclosed in the enclosure, which retains all temperature, allowing him to keep his process intact. So all of his problems have been solved. He doesn't have to unwrap his process to manipulate his manifold to close off or calibrate his instrument. His instrument is far enough away, the electronics are far enough away, that said, from his process so that he doesn't have to revolve or just reuse different transmitters over and over. And so we were able to do this in this application and in another one very similarly. You want to move forward? You can show them this one. So this is in the same part of a plant, but he was having the same issue as you can see here. Everything was mummified. It was very, very time consuming for them. And you can see he even used a different brand, thinking maybe the temperature ratings would be different, but nonetheless, we were having the same issue. We've been able to get these over to the customer, and he was actually very surprised that he was able to just plug the compression fitting in and resume his process.
Yeah, absolutely. Okay, so that wraps it up on the turnkey solutions in terms of the examples we wanted to provide, and just yeah, it's been a pleasure to work with the customer and with Vector's team together to find solutions for the customer. If there's something that you might be thinking about in your own application, or if you have questions at the end of this webinar, we'd be happy to engage with you guys on those things. So that brings us to the last thing that we wanted to talk about in today's session, and which has to do with the interlocking manifold. So maybe some people that are involved on this webinar are familiar with sill-rated systems. What we are showing here is on the left-hand side, it's an interlocking manifold. And on the right-hand side, it is a high-integrity pressure protection system where there's a voting system, 2 out of 3, which leads to a logic solver that takes a decision on whether or not the safety shutdown valves should be shut in or not. And so here is a graphic of a typical PNID of a HIP system. You've got on the bottom layer, you've got 3 manifolds leading to pressure transmitters, and ultimately your logic solver is making a decision as to whether or not to shut down these valves. A lot of times these are the last line of defense for a facility, a production plant form, a chemical plant, an FPSO, or a utilities plant as well. And so I kind of want to show you how it works. And so we've got one prepared right here. So the main thing when we talk about sill-rated systems is about instrument availability. And so if you work with these systems, you'll be familiar with the fact that a pressure transmitter, the highest sill rating out of 4, right? So the lowest being 1 and the highest being 4. The highest sill rating that can ever be attained by a pressure transmitter is a sill 2 rating. And that's based on probability of failure on demand calculations. And so if you have a system that needs to have, let's say, a sill 3 rating, how do you get from a sill 2 transmitter to a sill 3 rated system? Our customers and ISA 84, IEC 61508 on functional safety, these committees provide the guidance on how to make up these SIL rated systems. So if a pressure transmitter's highest SIL rating is SIL 2, then when you add another pressure transmitter into the system, those SIL 2 ratings put together turns the system into a SIL 3 rated system. Well, if you have a SIL 3 rated system, the moment you do any kind of maintenance on the pressure transmitter, you are taking one offline, then your system drops back down to SIL 2 rated system. And so a 2 out of 3 voting system is not just about two transmitters overvoting one transmitter in case one is malfunctioning, but it's also about maintenance. The moment you take one transmitter offline, you need to guarantee availability of the other 2 transmitters. So if I have a traditional manifold connected to all 3 of my pressure transmitters, anybody technically, we know that there's a lot of procedures in place and competent people working on this, but technically speaking, anybody can turn and close in more than one transmitter at a time. The problem with that is not just about instrumentation availability. If you drop down 2 transmitters at one time, you have the potential of having a false trip in your safety shutdown system. So once that shuts down, you're basically off. Your productivity is going to be halted, or in some cases 24 to 48 hours. So however much 1 hour, 24, 48 hours is worth to you and to your plant, making sure that there's not a false trip is a really big deal. Aside from the fact that you need to maintain that SIL 3 rating and instrumentation availability. So this is part of that challenge, right, that Shell asked us to solve for them 40 years ago, where they said, I need to guarantee instrument availability. I want to make sure that whoever's out there on the platform has to operate this manifold in the sequence that it was designed to perform. Okay, so here we have a system that is designed for SIL 2. And even though these 2 transmitters, when they're both online, make this system SIL 3, right? Because SIL 2 plus SIL 2 equals SIL 3. The customer in this case knows that once they perform maintenance on one, they're going to drop down their safety level to SIL 2. And so what we designed was a sliding key that doesn't allow you to isolate more than one instrument at a time. So let me give you an example. This sliding key can slide from transmitter to transmitter. But when I engage this key over this pressure transmitter, and if I just do not even a full turn, and I try to move up to the vent, well, I haven't fully isolated, so I don't want to be venting before I've isolated. I literally cannot, I'm mechanically designed out of moving up to the vent. I'm also mechanically designed out, let's see, I disengaged it. So if I turn this, I'm locked out from going into the next transmitter. I have to fully isolate out this transmitter before I can slide up into the vent position, where I can, I have a colleague who loves to use sound effects, vent the pressure to be able to perform maintenance on this transmitter. So this is something that we want to share with you guys today. It's been in the field for 40 years. The very first one we built is still on a Shell platform in the North Sea today. It's used widely outside of North America, but we see a gaining requirement for it as ISA 84 rules on SIL become more widely used and adopted, especially when you consider that many of these HIP systems out there are using manifolds that don't guarantee instrument availability. And I think a lot of times where the light bulb may come on for some is thinking, well, we've guaranteed the SIL rating on all the electronics, but then considering the fact that the one part, the manifold, the mechanical component of it is the thing that could make everything basically can waste a lot of the efforts in making sure that there's integrity in the electronic components. This is an area where we've been able to really make a footprint for ourselves around the world, particularly with the Abu Dhabi National Oil Company, in Kuwait with KOC, all over the North Sea. You'll find us on Statoil rigs, Shell. You'll find us in the Esso Belgium refinery. You'll find us all over onshore platforms, midstream projects, utility plants. It's really been something that's been adopted widely because it solves a glaring problem when it comes to SIL rated systems. So hopefully that sparks some interest and we can have more conversation about that. But that's where we are. That's what we had to provide in terms of examples today.
Hey, Caleb, can you only do it with those kinds of transmitters?
No. We just like to give people a hard. Yeah, we just like to give Vector a hard time here. Let's see. Try to move to the next slide, but doesn't seem to be working. So, do you think I could bother you to?
Absolutely.
Yeah, okay. There we go.
Have a little bit of technical difficulty there.
Yeah.
Anyways, let's go ahead and wrap it up.
Yeah. Okay. So in summary, the first thing we talked about, there we go. In summary, the first thing we talked about was instrumentation, needle valves, and manifolds. It's about the use of ceramics to provide a solution, which is to offer the performance of a bubble-tight sealing valve, but at the same time delivering the durability of a hard-seated valve. And then on the turnkey solutions, providing, as plants move away from welded connections, we're providing them fully welded assemblies, and we're doing it in a turnkey way that reduces the amount of involvement that the end user has to be involved in some cases today that we found. And then instrumentation hookups, yeah, it's been really fun doing that with you guys.
Absolutely.
Looking forward to the more coming down the road. And the interlocking manifold is something that is very unique to us, something that we're very proud of, and we hope to work with you on your SIL rated systems in the future. With that, we just want to open up the floor to questions, and of course, your contact information there is as well.
Absolutely. Pass it over to Nikki. Nikki, do we have any questions that have been posted through on the side?
We do actually. First question for you: has your manifold been fugitive emissions tested?
Yeah, great question. We have seen a rising requirement in fugitive emissions testing, and what we're happy to say that we are ISO 15848-2 certified. So that is tested with helium and measured in parts per million. So we're underneath 50 parts per million, testing using helium as the media, which is more than enough to meet the requirements of almost all applications. But in addition, there's a shell test, the FET 77312, that's required in some even more critical applications. Shell measures this in cubic centimeters per second. And so we can't just translate that number across. So we've done that test, and we've been able to achieve their highest grade for fugitive emissions. Thanks for asking.
Great. Next question. What is your standard manifold lead time, and has COVID-19 affected the product availability?
Yeah, excellent question. Again, our product is made in Holland, but we've been able to get product across. I think to be as honest and upfront as possible, there have been times where customs has held on to 1 or 2 shipments, but that's like 1 or 2 of maybe 40 or 50 shipments in that same period. So I think outside of the oddball, all the product is still making its way across. The supply chain within Europe has been able to hold up strong with the raw materials that we source from there. So standard lead times really depends, and I'm sure you hear that answer everywhere. When it comes to 316 stainless product, we're looking at a lead time between 4 to 6 weeks, unless we keep it on the shelf, which we do keep product on the shelf here. And then specialty alloys can be 6 to 8 weeks, but we've been known to help out customers in a pickle, just answering as broadly as we can.
Absolutely, and let me just go ahead and add to that. Vector has worked with many customers who have come and said, hey, I know that I will need X amount of quantity moving forward. Is there any way that we can get that allocated already? And we've made a commitment to our customers that we don't want to be we don't want to be the factor holding us up. So Vector and Astava have worked together very closely, in which at times we're able to forecast ahead and make sure that stock is moving forward. So as we start to ramp things back up and people start to get back into a normal state of life, we know that lead times will be a little excessive, but as we create a better partnership with you all and with Astava, we'll be able to forecast that better and hopefully minimize that lead time for you.
Yeah, and we do keep stock here in Houston. Yeah, just want to highlight that.
Okay, great. Next question. Does Vector do any evaluations of the system on site?
Go ahead. I'll go ahead and take that one. Absolutely. Vector has no problem coming down and walking down your application, providing any insight in which you request. I actually had a customer. They came to us. They approached us and they asked us, "Hey, can you come and look at this?" They were having a system in which they had all compression fittings, which is what was before what manifolds became. And their problem was they had to LDAR test, shoot the laser at everything and do their manual fugitive emissions testing there. And if we were able to come up with a custom solution for them, something that didn't necessarily exist in our part number portfolio, but we were able to work together again with Astava and make something custom for them in which we minimize the number of leak points for them. So yes, we'd be more than happy to come out. I myself, Caleb himself, your contact through Vector account management himself, we'd be more than happy to come out and do that for you. We also have a great service team which can come out and view these issues or problems or spot concerning points in your applications.
Okay, great. Next question. When I select manifolds, there are a number of orifice sizes to choose from. What size orifice is cut in Astava's valves?
Yeah, good question. I think in some cases there can be five different types of orifices that you can be choosing from. It's something that we wanted to be thoughtful about at Astava, and so we cut 2 orifice sizes. One is a 5mm orifice size, and the other is a 10mm orifice size. So basically, the 5mm, it covers the first 3. So anything we see, the 5 that we see out there, there's 2 of them that are out of the range of the 5mm. It's the 1/4 inch and it's the 3/8 inch. So we use 10mm orifices to cover those 2 sizes, and then 5mm covers everything else. As standard, in general, you're getting a larger orifice when you use an Astava valve.
Okay, great. Next question. What kind of packing options are available?
Yeah, so PTFE is commonly used for the chemical compatibility, but we also see a lot of requirement for graphite. And where it's suitable and the customer wants to use an O-ring, we do provide that in Viton, also in silicon O-ring as well.
Okay, next question. What kind of ceramic do you provide? And are there different kinds, and any reason that I should choose one over the other?
Yeah, absolutely. Not all ceramics are made the same. The one that we have used as a standard is AL203. So that's alumina. It's not made out of aluminum, but it's more of the type of clay that's used to make the ceramic. It is our standard because it is so widely compatible with different types of chemicals, and it's been a real champ for us. But at the same time, there are applications where if the system is meant for permanent or high-use steam services will retreat the Al2O3 and substitute that at no additional charge with a zirconium stem tip. So ZrO2 is the one that we use. So whether it's Al2O3 or zirconium, we're covering those. Those are the two that we're making available.
Okay, great. And we do have time for one last question. And the viewer wants to know, can you tell me a little bit more about Astava's enclosures?
Yeah, absolutely. So I think you saw an example of the enclosures when we were talking about the solution Devin was talking about. We used the glass reinforced polyester GRP clamshell enclosure to enclose around the remote mounted system we had mounted on that plate, mounted to the 2-inch pipe. So our enclosures we make in-house. They're GRP. They include insulation that's hot pressed and sandwiched in between the layers of GRP. So as standard, our GRP comes insulated. And then we make it in that clamshell with a latch, but we can also make it into a box that opens up. We can also make it into a box where you can completely take the lid off and make it in all different types of sizes and all different types of colors. For example, our standard colors would be an off-white or a black. But for example, in Germany, they were building one of their pipeline systems, and they wanted flyovers to not be able to see where all the instrumentation boxes were. So they asked us to do a custom forest green for them. But yeah, whatever the color really is, as long as the RAL number exists for it, we can make it. I should say that the enclosures are they can be IP67 rated. That's for the GRP enclosures. If we make a stainless steel enclosure, then that will be an IP66 rated enclosure. And really the drive to making all the GRP IP67 comes from the need to make the junction boxes IP67 rated in case those electronics are being housed in an outdoor environment.
Okay, wonderful. Well, I'd like to thank everyone for joining us today, and we trust that it was a worthwhile experience for you and you learned from our experts some valuable takeaways. Any closing comments from Devin or Caleb?
Absolutely. Thank you, Nikki. First, we'd like to thank all of you for your time. We'd like to thank Caleb for joining us. Everyone, we're in the business of providing solutions for you. We hope that we've provided some helpful information here. As you can see on your screen, we have coverage all over these 7 states. Caleb and mine contact information is there if you guys need anything. Hope you all stay safe. This year in 2020, Vector's motto is one more. So we ask you guys for one more challenge and one more partnership, guys. So thank you for your time and hope to see you soon.
Thank you so much.
Have a great rest of the day.